Good morning, good evening, wherever you are. I'm glad to have Kaushik and Shiva again here. And last week's we have been talking about microservices, event-driven architectures, and this time we are shifting our attention to reactive programming. Welcome, Kaushik. Welcome, Shiva.
Good
Thanks
to
for
be
having
back
me,
here.
Anga.
If you guys, we actually skip the introduction part most of the times in our sessions because I assume that most of you know Kaushik and Shiva already based on our previous sessions. But if you have no idea about who Kaushik and Shiva is, shall we start with a quick introduction, Shiva and Kaushik? Shall we start with Shiva?
Yep, I'm Siva. I'm from India, currently working in a small startup called Everest Engineering in Hyderabad. I have around 15, 16 years of experience. I mostly worked on Java and other JVM based languages. Um, yeah, apart from my regular work, I do write blog, sivalabs.in. And yep, that's pretty much about me.
Yeah, I think that the work you did on shivalabs.in was what actually I saw. And that's where it led to us meeting and over a period of time to this discussion over here. Thanks a lot, Shiva. And probably almost all of you know Kaushik. Kaushik, a quick introduction, Java Brains.
Sure. Yeah. My name is Kaushik. I'm a Java and JavaScript developer. I work at LinkedIn, and I also have a YouTube channel called Java Brains, where I teach some of the things that I know.
A very interesting aspect is the latest thing which Kaushik started, the podcast. Do you want to talk about it, Kaushik?
Yes, sure. Thanks, Shiva. Thanks, Ranga. So yeah, I have recently started a new podcast as well called The Artifact, where the goal is for me to share some tech news in detail and also interview people, get people who have done something related to programming and our software industry in general, and ask them questions and get the benefit from their experience and knowledge. It's a podcast, so you don't have to be on YouTube or something like that to watch all the time. You can play it when you're driving or something like that. Download it on your phone and play it. You can subscribe and you get episodes automatically. So encourage people to give it a try. Theartifact.io.
Absolutely. I regularly listen to a lot of podcasts, and now I have another one to add on to my list. I love the last episode regarding architecture, Kaushik. The
Thank
journey
you.
of how somebody can approach the journey from being an individual contributor to like becoming more take more ownership and grow onto a architect role or probably into project management. I think that was a
Yeah,
wonderful discussion.
thank you.
Cool. Let's get to the topic of the day. We wanted to talk about reactive programming. Uh, Usually, we are used to the request response model. If, let's say, I have to talk to a database, I have to send messages. You have all the processing starts with a request, and that thread is waiting until you get a response back from the database. You have a response back from your queue, and at the end, you would send a response back. This is kind of the traditional request response model that we are used to. How is reactive programming different? Kaushik?
Sure. So reactive programming is a different way of thinking about doing things when you are handling such a request response on the server. And honestly, it's not even about server based programming. You can apply reactive programming to anywhere. Right? You're writing a hello world application that runs purely on the desktop. You can approach reactive program. You can build it using reactive programming. Um, Reactive programming is a different way of thinking about uh, concurrency and threads in your Java application. Traditionally, Java is thought to be a blocking kind of a paradigm when you write code, right? So let's say I'm going to give a server side analogy, but this applies not just to server side, it applies anywhere else. So let's say you get a request, you're building a web application, you get a web request, and you're writing your code which goes and queries a database, returns some records, and then gets it back to you. and then you process those records and then send it back as an API response. Typically, what tends to happen is each one of them are individual blocking operations which are executed synchronously, right? You have one line of code which goes fetches the data from the database, and then the line of code below it is waiting, right? It's not executing. It waits until the return happens, and then it executes. And then if that's doing something IO intensive or network operations, again, the thing is waiting. Now, what does it mean to say something is waiting? What it means is there is a thread on the server, and that thread is currently paused on hold because there is an IO operation. Something is taking time. Usually, what ends up happening is when you have a web application where there are a lot of requests and a lot of IO operations, a lot of database calls and network calls, you have a lot of threads waiting like this, right? So a lot of blocking operations results in a lot of threads. The thread is short-lived, probably, right? You get a response back and then it goes back. But then since it has to wait, since it's synchronous, you end up with a certain point where you go, well, yeah, my server isn't doing much. There's a lot of resources getting consumed just because these threads are waiting. And this is a side effect of these operations being synchronous. Reactive programming provides a different model. And for those of you who are familiar with the way it works on the JavaScript side, like the Node.js or even client-side JavaScript side, this is going to feel, you're going to feel very comfortable with this. Basically, the idea is you have one way to solve the problem is you can use something like callbacks. And you can say, hey, I'm going to go fetch this database call. And once the database call completes, I'm going to give you a function. You execute it. I'm not going to hang around and wait, right? Which is what the thread wait operation is. You give it a function. After you get the call, whenever it is, just execute this function, right? And then a Lambda, and then you can execute that. That's typically how it works in the Node.js side of things. So with Java, you can do callbacks, but it's painful, right? You can pass Lambdas around, but then it's hard to track errors. It's hard to manage a flow and all those things. Even if you were to do some of the newer constructs, like you use futures or completable futures, it's hard. Error handling becomes hard. Completable futures are a little better at handling this, but it's still a problem with handling errors. Reactive programming is a different paradigm of doing the same thing, of doing this thing about, I'm going to perform this expensive operation. And when that expensive operation completes, you're going to react to the completion by doing the other operation. You're basically having these things set up so that when this completes, do this, and when that completes, do this. You're not actually waiting for it to complete. So that's a different mind shift. And that's basically what reactive programming is about. It's about understanding the APIs and paradigms that go with this mind shift.
Absolutely. Absolutely. Shiva, your thoughts?
Yeah, I would say reactive programming is like traditionally we used to deal with finite amount of data, whatever the data you have in your database or whatever, you read and you manipulate and then you send back the response. But in the recent systems, due to IoT devices and then social media streams and all that, you are getting a stream of data. It's not one set of data. You are going to continuously receive a stream of data. So you need to handle that stream of data in a way that, okay, as you get more and more data into your system, you should be able to react to it and then process it accordingly, instead of simple, straightforward, old style request and response model. So the applications are multi-faceted. Like one of the application is, let's say you have a Kafka messaging broker, and some system is keep on pumping the data to the messaging queue, and then you need to process it. That is one way of processing it. Another way is maybe you are running a server application and you are keep on getting a request. So the input is kind of a different ways you can get request, and then how do you react to that? It's not a simple request and response model. How do you react and handle it? But to get into little more details, how it actually handles is traditionally, as Kaushik mentioned, when you want to process something, you make a request, maybe you process some in-memory computations, and then you try to read data from database or write some files to hard disk, something like that. In that process, your CPU, your thread is going to stay idle. until the process is completed, and then it will continue once the processing is done. But in the typical server environment, let's take an example of a Tomcat server. By default, it creates 200 threads, and then let's say you've got 200 parallel requests, and all the threads are occupied. Now, some of those threads might be simply waiting to do backend processing, maybe reading from database. Now, if you get more and more requests, they need to wait. So from the client perspective, they just got hanged. They are not getting any response. So instead of doing this, if you have a mechanism where you just trigger and then you can free the thread and let a notification get triggered back to you once the data is ready, so that meanwhile your thread is released and it is able to accept new connections. So this way it is making system more responsive and then efficient use of threads. You are using the threads and system resources in much more efficient way and also able to accept more and more requests. So it's kind of a different programming paradigm, but you need to think in terms of data stream processing instead of request and response model.
Absolutely, absolutely. One of the important things I guess both of you touched upon was the blocking versus non-blocking. I think that's something which, let's say I've worked in Java for a long period of time. That's something which takes a little bit of time to figure out what is a blocking request, what is a non-blocking request, and how do you really start writing things in such a way that it becomes non-blocking. Kaushik, do you want to elaborate on that?
Sure. Yeah, it is hard, especially when some of the Java constructs that have supported async have eventually been blocking. So, for example, if you look at futures, or again, like I said, even completable futures, right? So when you get a completable future, you are supposedly using it for asynchronous operation, but in order to get the value from the completable future, you have to do a join, and that's essentially blocking, right?
Exactly.
So the native Java APIs haven't helped in that sense. The problem with blocking is this, right? So let's say let's take a simple operation of you making a request to get user information, right? You're an API to get user information. User information is in the database. You write a controller which goes, fetches data from that database, and then maybe does some manipulation and then sends it back to the user, right? A REST API response. So when you're doing a call to a DAO, right, or like whatever it might be, a JDBC layer or whatever, right? So you're making a call, you're getting that response back. The key is to inspect what the return type is, right? If the return type is the data itself, that means that you're essentially waiting for the data to come. Okay. However, if the return type is a wrapper, in the case of, I'm going to give futures as an example because that's kind of baked into the Java language. If you get a future that's a wrapper around the data, the wrapper not in terms of what state it holds, but like a future state, right? So it's a future state wrapper. So that is a sign that you're possibly doing a non-blocking operation. Anytime you kind of hold on to the data itself, right? When you get a future object and then you do a dot get or a dot, I forget what the name of the future is. I don't know, completable future, you got to do a dot join. So when you do a dot join and you get that user object back, well, that's blocking. So I think a good clue is to look at what is the return of the method. Is it the object itself, in which case it's blocking, or is it some kind of a construct that's a wrapper around that object, like a future or one of the reactive objects, in which case you're probably doing a non-blocking operation.
Absolutely. And when it comes to languages like JavaScript, they are non-blocking almost by default, right? So how does it work in JavaScript?
The way it works in JavaScript is they don't have these wrappers around it because you have callbacks used extensively. And all these wrappers with future and all that is a way for us to kind of hide the fact that async operation is happening, right? When you're doing something like this, right? When you're calling a method and then method is returning a future, you're kind of trying to have the user write code almost as if it's synchronous, right? You get a future object and then you do future.get. It's like you're kind of enforcing, or at least helping the programmer get to a synchronous way of thinking. If you start thinking about async, Java programmers tend to get confused. They tend to not like it because we are used to a synchronous way. So this is one way of kind of hiding the fact. JavaScript is unabashedly asynchronous. It doesn't try to hide the fact, and
Exactly.
JavaScript does have the concept of promises, which is kind of an equivalent analogy of futures. Right? Just like you can do a future dot then, you have JavaScript promises, which is has a dot then. It's like analogous there. So you can kind of reason with asynchronous using synchronous styling with JavaScript. They also have async await, which is another way of hiding it. But people typically tend to know. It's just the way you think about it in JavaScript. You kind of start thinking async. So
Right.
even when you do async await, you have to kind of go in knowing that this is an asynchronous operation and you're waiting for something to happen. So there are equivalent constructs in JavaScript as well, but it's a little more obvious in JavaScript, is my personal opinion.
Absolutely. Anybody who has worked in full stack development projects, I think they would know that, right? Whenever we actually call a REST API, for example, in your JavaScript frameworks, whether React or Angular, the thing which we tie up it with, it's some kind of callback mechanism. So once I have the data back, this is what you need to do. And that's kind of fundamentally built into the JavaScript language. And yeah, I think, as you say, for most of the Java developers, we are more familiar with synchronous operations rather than asynchronous things. Shiva?
I, I would say not just Java developers. For most of the times, almost most of the languages, imperative sync style is a natural thing. Because we want to have this async way of doing things, so that our machines perform in a better way, in a resource efficient way. We try to do in async way, but as a human, our natural process is, okay, we want to do something, step one, step two, step three, we go sequence one by one. uh, I would say it's natural for most of the languages, even Java or JavaScript or Golang, any developer. Synchronous processing is very natural. But again, different languages evolve in a different pace, right? JavaScript has async await promises and all that. And recently, I get to know .NET, C# .NET also has async await, and Java has completable futures and all that. Now, reactive programming, uh, kind of more or less, many languages have those features, and depending on programming cultures and all, some communities adopt rapidly than other communities. As we all know, Java community kind of move in a bit slower pace, where they adopt these new styles in a more kind of they try to see whether it is going good or not, and then if it is looks good, then they slowly adopt. uh, yeah, so kind of I see most of the programming languages has these features built in with a varying different levels of usability. But I agree, JavaScript wise, it is very easy, especially with async await. It's very easy compared to other languages.
Absolutely, absolutely. And one more difference with respect to Java and JavaScript is also the uh, availability of functional programming constructs in JavaScript from the start. Like almost like from the initial versions of JavaScript, from initial versions of Python, they had functional programming constructs built in. However, Java was a little late into the game. We had to wait almost until Java 8 before we had functional programming possibilities uh, in Java. And one of the things I observed is functional programming makes reactive programming easy, right? Because a lot of times what you're doing in reactive programming is kind of tying up a function, some logic that you'd want to do with a specific thing that you're waiting for. Uh, Kaushik, do you want to elaborate on that?
Yeah, I think Lambda has made a big difference in terms of doing any of this stuff. I think that was a big shift in how you think about it. Because again, like you said, the language constructs affects how you think about concepts in programming. And it's not just programming. They say that in our language as well. There has been research which conducted that the way our spoken language works, right, our mother tongue or whatever, right, whatever the constructs affect the way we think. So language is a very powerful thing. So even in programming, um, the introduction of Lambda and kind of almost, I wouldn't say fully, but almost treating functions as first class citizens, being able to assign a lambda to a variable, have it passed around, is critical to functional programming. We were doing kind of hacky functional programming before with inline classes and anonymous classes and all that stuff. And it used to be like, yes, you are doing functional programming, but you cannot think of it like that. You still had to think that, okay, I'm creating a class on the fly and creating an instance of it, because it's just extra overhead to your thinking, and you cannot really kind of wrap your head around object instances being just behaviors, right? It's like an object is supposed to be data and behavior for that data, right?
Right.
You have, anytime you're looking at like this anonymous inner classes, you're just passing behavior, but you have to wrap it in a class because Java wants it. So now with
Absolutely.
lambdas, that kind of opens it up. And also with the introduction of all these different stream APIs with collections, people now do functional programming with Java as second nature. We're used to processing things, creating a stream, doing things on top of it, chaining all these operators. It's kind of like now functional programming is a little more comfortable for us Java developers. Reactive programming kind of takes it to the next level and says, okay, you've been doing all this kind of style of functional programming with a fixed collection where you know all the data up front, and you're basically going to transform that into like an possibly endless stream of data that may not all be there. If you can transform a collection of 10 elements, how does it matter if that 10th element is happening now or it's happening probably a little later down the line? You kind of split it based on time. The same paradigms apply. So I think that's a one good thing about reactive programming. It kind of follows the stream and the functional programming paradigms that we know and we love about collections already in Java.
Absolutely, absolutely. I think it does help to build on the functional programming aspects. For viewers out there, if you are not familiar with functional programming yet, please go ahead and learn. I think functional programming is not only results in readable code, but also it is very very important tool in your arsenal. As we go further, I would think there would be a lot more use cases where it's imperative to learn the non-imperative style, which is functional programming. Shiva, last week we were talking about event-driven architectures, right? So in event-driven architectures, we were at a high level. I mean, we were kind of, I think, architecturally, we were at a higher level because we were talking about interactions between applications rather than what's happening inside an application. How do we handle? So rather than inside a single thread, we were actually talking about maybe inside a single thread, but how do you communicate with other applications and things like that. So how do you I mean, it can be a little bit confusing for people, like event driven versus reactive. Anything that you can do to make it simple? Any thoughts there?
I'll try, but still, I can explain what I understood. But still, there are a lot of gap that I don't fully understand the low level kernel level things, how it happens. Actually, when I first heard about reactive programming, in theory it looks good and easy. Okay, you got a request and you don't block on anything. If there is anything blocking, it will release the thread, and then once the data is ready, it will resume. And then, in theory, it looks simple, straightforward. But taking a step back, and who worked on traditional request response model for a long time, it is really difficult for me to understand how, especially in the context of a web application, how it actually works. Again, going back with the request response model, typically let's take a Tomcat server. As I mentioned, in a Tomcat based application, you have a fixed thread pool. Let's say by default 200 threads are available. As soon as a request is received, a thread is allocated to process that request. And then we have our own application logic to handle how to process and all that. So the entire processing is handled by that particular thread, right? So now we are saying, and again, we know HTTP is a stateless protocol. It doesn't know about the subsequent calls or anything like that. You get a request and you process it, and then you send back the response. End of story, right? So now how this actually, okay, we are saying a thread is going to receive the request, and then as soon as it receives a blocking operation, it is going to release the thread, and then it is going to continue once the data is ready. So where this link is happening, like the thread is getting released, which is associated with the web request. Ideally, we should be sending the response to the same thread, same socket connection, right? So we are saying it is releasing now, and then later it is getting notified. How this loop comes back to an end state? How does it know once the data is ready which thread this is associated with, and to which client it needs to send back the response? There is kind of a missing logic. I couldn't understand how this end-to-end flow works. Later, I kind of was trying to understand a little bit how things work. So this is what I understood. Still, there are a few gray areas that I don't fully understand. So it's when we talk about HTTP request processing, right? It's all about, and under the hood, it establishes a socket connection, and you have a reference to the socket, and then you process, and then from the our application point of view, we implement all kind of logic, and then send back the response, be it JSON, be it HTML, or whatever. But under the hood, you are writing that data to the socket, which is the client is going to receive it, right? So in this all mumbo jumbo of releasing the thread, and then again getting notified after the data is ready and all that, somewhere they maintain for which request what is the associated socket object for it. So, and under the hood at the kernel level, again, Windows implements in a different way, Linux implements in a different way. But at the kernel level, there is a different ways of handling things. Like now, there is a feature where you try to perform a blocking operation, be it reading a file on hard disk or reading data from a database, whatever. So when it comes to executing those operations, it is going to release the thread, and then once the operation is done, I mean reading the data is done, it is getting notified via file descriptors. And then at the operating system level, it triggers a notification. And then again, all this, whatever the server implementation, be it netty or whatever server implementations, they kind of plug in again the socket back into that handler callbacks. So we don't implement it in a callback style or whatever. But once we implement, let's take Node.js or Mono, Flux, whatever. These are all kind of callbacks. Internally, they handle it in a callback style. So it gets notified, plugging in with the same socket reference, and then it pumps the data back to the client. So that is how internally it handles. So a lot of detail happens at the kernel level, how it is releasing the thread, how it is plugging back into the same socket connection. Most of this logic resides in some of the logic is in operating system level. Some of the logic is handled at the server level, like netty or under2. So they do the heavy lifting, all this plumbing back into the connection and all that. From the application developer point of view, we are shielded from all these details. We don't care about how it actually happens. We simply put a annotation, and then we receive request, and then we query our Spring Data JPA repositories, whatnot, and then plug it back and return a Flux or Mono. But under the hood, a lot of these things happen. Most of the times people are happy, okay, I'm able to plug in all these things and things are working fine. But if you want to understand, there is a lot of complexity happening under the hood, which takes a bit of time.
Exactly.
And
Exactly.
one very important thing to understand is probably anyone who work with Node.js already know this event loop thing, right? So earlier in a traditional web application request response model, as I mentioned, once you get a request and you are processing, all that processing request processing is tied to that particular thread only. So if something goes bad, only that particular thread is going to get affected. Whereas in this event loop thing, one thread is multiplexing all the requests, and in this process if you invoke some blocking operation, it is not only affecting that particular request, it is halting the overall all kinds of requests. So same thing for reactive programming, be it webflux or whatnot. So that is why you shouldn't simply, okay, let me use webflux on the web layer, but I'll talk to a database to get all the data. No, it doesn't work that way. It is going to block the thread. So you need to have this end-to-end flow, which is in a reactive fashion. You cannot put
Exactly.
bits and pieces. It doesn't work that way. Though you are leveraging in one layer, under the hood, you are again blocking at the data layer level. But again,
Absolutely.
there are because when you think of reality, right? Most of the Java libraries are designed and developed thinking in a blocking fashion. Now we cannot simply throw away all that developments, right? So I guess I haven't really used, but I heard in Vertex, I think one of the reactive library framework, they have this offloading all this blocking operation in a different thread pool and handling all this reactive style handling in a main thread pool. There is a way, but I haven't actually used and implemented by myself. But there are ways to do this. But important thing is, if you want to go with the reactive programming, think you need to go all the way in a reactive fashion,
Absolutely.
using reactive in web layer, but doing a blocking operation on data layer. You are not going to get benefit out of it. In fact, you are
Absolutely.
causing more trouble.
Absolutely. So, what you're talking about, Shiva, I think you touched upon a lot of very, very important points there. So, I'll try and focus on a couple of things. Right, there were a lot of very, very important things out there. Um, First thing is the entire flow should be reactive. We are used to, let's say, I'm using Tomcat to deploy a traditional application. The Tomcat is probably based on the servlet API, like kind of a thing, right? And on top of it is where we build all our servlets or controllers. So, and probably I'm making use of a Hibernate to talk to a database. Probably I'm talking to MongoDB, I would be using a library. So, what you're talking about is the fact that it's not sufficient if you just use Webflux, but it's actually the entire chain which needs to be changed. So, your web server, whichever you're making use of, should be reactive. Also, the libraries you're making use of, they should also support the reactive model. So if I want to use a JPA, you should go for JPA reactive, MongoDB reactive kind of things. I mean, there is a lot of work on in progress to create reactive libraries. I mean, I think most of the libraries are already there. So it's the entire flow that needs to be reactive. However, one of the flexibilities, I mean, probably I think before we get into further things, probably we can just touch upon at a high level the landscape in Java for reactive programming, right? So we were talking about uh, Webflux, we were touching about
Vertex, yeah.
reactive streams. Yeah, so just let's focus on the Java side of things and look at the high level landscape of things. Kaushik?
Sure. The most popular. I'm going to start with the most popular option today is Spring Reactive with the API support that they have. They have kind of adopted a project called Project Reactor, which has the reactive paradigms for working with building APIs. Like Shiva mentioned, right? You have to build it all the way, and with something like Spring, all the way includes framework support. So imagine if you're building like the example that I gave earlier, you're creating a controller, and the controller returns the object itself. Well, now you're blocking in that return step, right? You're going to have reactive through and through, and that includes framework support. So Project Reactor and Spring is kind of like the most popular option. But what a lot of people don't realize is that the core reactive interfaces are a part of the Java language. Okay, so there are a couple of classes which are essentially interfaces which are essentially a part of the Java language, which is for the publisher and consumer paradigms. I'm not able to recall exactly what they are. I think it's flow and
Mono and
mono, but it
Flux.
could
Mono
yeah,
and Flux.
it's Flux, yeah. So I think all these different. So one of the reasons why it was introduced as a part of the Java language is to kind of standardize it. But the features of the it's basically standardizing the producer and consumer concept in Reactive. But I have usually not used it, which is probably why I don't remember it. What I usually tend to do is go with the project Reactive paradigms, where I use Flux and Mono, which are two ways of producing these kind of like these reactive streams, and you kind of chain all these operators on top of it to use it. So a lot of other reactive frameworks have a similar concept, but these are the ones that I'm super familiar with. I haven't played around with the other ones, to be very honest.
Cool. Shiva, any thoughts there?
Yeah, as far as I know, I think RxJava is the first library that brings reactive programming into Java. Later, we have Project Reactor, and then Java tried to standardize using Flow. I think they introduced in Java 9. But these are the two major ones. But coming to think about the frameworks, we have Spring Web Flux, and Vertex is another one. I think Quarkus and Micronaut also supports reactive programming. I think major frameworks support reactive programming these days. But these are under the hood. These are most two things: RxJava and Project Reactor. They provide a lot of operators, how to deal with the data streams and all that. Yeah, I think in Java these are the major frameworks.
Absolutely.
I was just curious if you've played around with those, Quarkus or Micronaut. I'm aware of them, but I haven't used them myself. I was just curious if you've played with it and how you see that in comparison to, Spring support with Project Reactor.
I would say,
go ahead, Shiva.
I would say, as you are very familiar with Spring Boot, I think it takes a few hours to get up to the speed with either Micronaut or Quarkus.
Yeah, exactly.
Not even days, few hours. That's all. And most of the concepts and everything is same. And another thing is, like Spring Boot does, it hides under the hood things in an abstraction level, right? Same, Quarkus does the similar thing. Even though they are using most of the microprofile API implementations and all, they are shielded from you. You program with JAX-RS, things like that. Under the hood, it delegates the implementations. So yeah, anybody who is familiar with Spring and Spring Boot, it doesn't take much time to get on board with Micronaut or Quarkus. And one thing I really, really liked about Quarkus is finally we get this JavaScript world's hot reloading into Java world. Like you change the code and it automatically restart. It's not going to take seconds also. In a millisecond time, it just restarts. I think
cool.
if you say this in the excitement to a JavaScript person, they say we have this a million years ago, but it's a big deal in the Java world.
Absolutely. I was able to actually migrate. Like I had almost 55 Spring based projects I had created, and I was able to actually migrate all of them, or actually not really migrate. I was able to use Quarkus and Micronaut with them in about 3 days. So I was able to actually change all those projects in 3 days without having any knowledge of what Quarkus or Micronaut is. So yeah, it's pretty simple, as Shiva said. It's just actually they're more adherent to standards. So if you look at Spring MVC, it's not really compliant with whatever the Java EE API or the Jakarta EE API
standard,
for that is, right? Yeah, exactly. And it's also not compliant with microprofile APIs. But Quarkus and Quarkus and Micronaut are compliant with them. So it's the annotations are a little different, but most of the times you'll be able to easily figure out the approach is exactly the same. Nothing changes
Cool,
with the
cool.
approach.
Yeah.
And the
The
other major
interesting
difference is the
thing.
containers thing. So
The,
because I think, go ahead, Shiva.
go ahead. Anya.
So, like another interesting aspect about Quarkus and Micronaut are the fact that they are built for the container world. Like in Spring, it's more of a later thing. So,
It
like
got
there
tagged
are
on to it later.
workarounds.
Yeah.
So, but these things are built for the container world. So, things like startup time, memory consumption, these are really, really important when it comes to those two frameworks. Shiva.
Yeah, Micronaut is even much more interesting because you literally change the imports, not even don't touch any of the actual code, just change the imports because even the names are exactly same as Spring Boot. There will be a chance that you just change the imports and it becomes a Micronaut application.
Absolutely. I think there was a lot of work which was done. I think if you look at the evolution, right? So it was Spring, long time, long gap, and then we had Micronaut, and then Quarkus.
Right.
So I saw actually Micronaut getting a little bit of traction before Quarkus came in. And once Quarkus came in, now I would say almost there is no traction for Micronaut at all. Not a lot of people are using it at all. And it's if somebody is going for a Spring alternative today, I would think it's Quarkus. So, but I mean, but again, it's kind of the same debate as Maven versus Gradle, right? I mean, Gradle is definitely better than Maven in terms of the feature set, but the difference is not substantial enough to force people to go to Gradle. And I think I see the same thing in play with respect to Spring versus the new frameworks. They're not substantially different. I mean, they have added value in few spaces, but they're not substantially different to force somebody to make use of it, because as we discussed throughout these sessions, it's not just about building code, right? There are a lot of ecosystem kind of things that come into play.
Got to break the momentum, right? Yeah.
Exactly.
Yeah. Cool.
So if you look at it, probably like we'll go back to our discussion on where we started off, right? So basically, I think what we were talking about is the fact that reactive programming is supported in all Java frameworks, right? So it's not just Spring Reactive. There are like it's almost in like because like the frameworks like Micronaut, Quarkus are more of a late starter. They had the advantage of like seeing the fact that reactive is getting popular, and therefore they are already built into these frameworks. Cool. Okay, I kind of lost uh, the thread there. Yeah, I think one thing which we were talking about is the fact that when we build a flow, the entire flow should be reactive. But like it, but let's say I have an application with 100 flows. Not all of them need to be reactive, right? So if let's say I have an application with like let's say 15 20 flows, we can probably trial one of those flows to be reactive entire end to end and leave the other ones being non-reactive. Is that your understanding too, Shiva? Is that the best way to go towards reactive approach? Let's say I have a project where I'm not using reactive at all and I would want to trial reactive somewhere. Is that a good approach to start with?
As far as I know, yes, you can combine both Webflux and web way of doing things in the same application. But again, you need to make sure if you are thinking you want to go for this particular endpoint, you want to go with the reactive style, you need to make sure that all the end-to-end processes are adhering to the reactive standards. And as far as I know, you can combine both reactive and normal web styles in the same application also.
Absolutely.
Yeah, that makes sense, and that is true. You can combine the two, but the tricky part is to make everything reactive. The problem that usually tends to happen is when you have, let's say you're doing just controllers, right? You want to say, okay, this controller is traditional way, this controller is the reactive way. Yes, you have separation into the controller, but then what happens beyond that, right? There's some point of time we're going to have to call a data access layer. Now, what you will end up having to do is create two signatures or two different methods, right? One method is, or one, JPA class, which is returning signatures for the traditional approach, and the other one for the reactive approach. So you end up having to duplicate that. So
Absolutely.
people typically tend to have better luck when they're trying to build a new feature that they don't have existing methods and services and data access layer on that they have to duplicate, and instead just building something from the scratch. One other advantage is with microservices. You're spinning up a new microservice, refactoring the monolith into a new microservice. You can say, well, this part I want to make it reactive and go from there. So yeah, technically possible, but make sure
Right.
you don't fall into the trap of your front layer with your Webflux part is reactive, but then you're bound by blocking because your data layer is not supportive of that. So you got to be careful there.
Exactly. So the complexities will be
Yeah,
more around the fact that you need to have support through the entire flow, and therefore you would have both reactive libraries and non-reactive libraries for, let's say, the data layer,
Right.
and probably your business layer as well, and duplication and all those kind of challenges come into picture. Shiva, please.
yeah. Not only database level blocking, there are various other things also to consider. Like many Java libraries, they leverage thread locals. So when you are using reactive programming, as we mentioned, the flow could be handled by different threads at different time spans. So you may not assume that you put something in thread local and you can get it from in a different place. It may not work. So you need to be very careful adopting libraries and make sure it is really working. Otherwise, it's going to be like a lot of surprises. Like you may assume, okay, it's working, but somehow it is not working in reactive. So a lot of effort needs to put in to make sure it is working in the reactive fashion.
Yeah, absolutely. The reason I'm bringing this point up is because if you look at most of the videos around Spring Webflux, Spring Reactive, one of the things they really highlight is the fact that you can use reactive in a part of the application. Right? They try to actually focus on that to tell you that, okay, there's a specific part, you can probably decouple it and you can use reactive. And the fact is, when we go to the real world, when you're implementing in a project, even though technically it's possible, there are a huge amount of challenges with respect to doing it practically. And probably I think that's where, if I can summarize, I think we are like more going towards an approach where if you really want to go for a reactive style, probably separate it out into a microservice of its own and probably try it out there rather than trying it in an existing application. Is that a right way to summarize that, Kaushik?
Yeah, that'd be a right way to summarize it. And you get an additional bonus there, which is reactive programming is very helpful in certain microservices, which are kind of orchestrators, if you will, right? So you have there are certain, sometimes in the architecture you get these microservices which are their sole purpose is to call other services, get the data, kind of mangle it, and then send it back. So for those kind of services, usually they tend to be bottlenecks in terms of you want to have a good fault tolerance strategy there, because let's say one of the dependent services down the line is choking. Now we have all these threads piled up. With reactive programming, you have an easy way of solving for that. You can have fault tolerance strategies right there in the code. You can implement wait in your reactive change. You can say, okay, wait for this much time. If it doesn't return by then, use this other service, or have some kind of a backup response that you get back. Like you can do all of that very elegantly in reactive programming. So that's why I think one of the reasons why a lot of people adopt this combination of Spring Boot and reactive, because you can do all this microservice orchestration scenarios very well with reactive.
Absolutely. Cool. One of the,
Another,
I think one of the things you
another
touched upon,
yeah, go ahead. Go
uh,
ahead.
one of the things you touched upon, Kaushik, was error handling. And because reactive programming came in a little late, one of the big shifts I see with reactive programming is to treat error as a first class citizen, right? It's no longer something in the background, like exception handling or something like that. It's typically like you kind of add a try catch and make it kind of an additional thing on top of what you do. But somehow, like with reactive programming, I see that error handling is actually part of the code. Like if you look at any reactive interfaces, you always have an on error interface. What should we do if there's an error? Your thoughts on that, Kaushik?
I think it's again, as with a lot of things that you're going to have to think differently with reactive. This is also one of those things, because this is not true just in Java. I've had problems with this in JavaScript as well. Errors and async are a big pain. Okay, our traditional exception model, where somebody throws an exception and then you have this stack of like this call trace and somebody else catches it. There's one thing that it assumes. It assumes a single thread, right? A single thread which is doing all this stuff. When you have async, it becomes a big problem in terms of, okay, the thread which called you, which invoked you, is not there anymore. Now, what does the concept of bubbling up mean? Because there isn't like, for a call trace to happen, it has to be a single thread where one is invoking another, which is invoking another. That concept, that notion goes out of the window with reactive, right? So what is calling a certain method which could potentially fail is not the same thing that called the parent who invoked this guy. So when this fails, how do you notify the consumer of this thing that this thing failed, right? So how do you replicate that? So the way it works with reactive programming is you do that using operators, just like you do everything else. And it's also useful that anywhere along the chain there is an exception that happens, it bubbles up as well. So one of the concepts which is very common with reactive programming is you end up with um, a flux which is calling another flux, which is working with a like an array of fluxes or a list of fluxes and so on, and you're flat mapping and all that stuff. You're working with two different streams, merging them and whatever, right? So the thing is, no matter which of those sub streams you're working with has an exception, has an error, you kind of catch that in your paradigm. So it actually frees things up. It's like, okay, do I have to catch it here? Do I have to catch it there? It really doesn't matter. It's just another operation that you put in and you handle it. So there are certain key points for a stream to end. Okay, so a stream can say, okay, I'm complete, I'm done. So there is an on-complete event which indicates that the stream is done. There can be an event itself which is a part of a stream. You can get like a data element which is a part of a stream, or you can get an error which is also something that causes a stream to end. Okay, so in that sense, what you said is right. An error is treated as a first class citizen, and that error is one of the possibilities that you actually code for. It's not an exception anymore, even though we have to use the exception paradigm. Because traditionally we've thought about exception as something that's outside of the norm, right? Something that should not happen, but if it happens, we do this. But with reactive programming,
Exactly.
we kind of plan for it. It's not so much exception in the English meaning of the term, but you
Absolutely.
have operators treated just like you treat data, which is a very freeing concept, in my opinion.
Absolutely. I think with the evolution of distributed systems, cloud, one of the most important things that we realized is failures are normal. Things don't happen as you expect, and it's very, very important to think about that. And I think reactive programming helps us do that when it comes to building reactive applications. Shiva, sorry, I interrupted you. You were about to say something.
No, I was about to say same thing. Like when you are building reactive applications, you need to think in a different way. Like you are processing a stream of data. So what there are only three possibilities. One, if there is more data, you are going to get some data element, or you get a notification that says all the data is already sent. There is no more data, or you get an error. So you need to code your data stream processing in such a way that expecting these three things can happen. So traditionally we do like step one, step two, step two, step three, and then if something goes wrong, you handle it in try catch, right? So that doesn't work here. Here you do a pipeline where step one is doing some transformation and pump into next step. So it goes in a staged manner. So you need to accommodate this exception handling as part of events. It could be an element, it could be an indication that all the data is already sent, or it could be an error. So that way you need to approach. There is not really a try catch way of doing things. This is how you need to think about it.
Absolutely, absolutely. Yeah. Let's shift track a little bit. I think we were talking about most of the technology aspects related to reactive programming, and also like some of the patterns and best practices related to how to build reactive applications. Um, we'll probably talk a little bit about, let's say I'm a beginner to reactive programming. What would be the best place to start? Like, what would be the things I would need to focus on, and where can I start? Shiva, do you want to start?
Yeah, especially for Java programmers, I think the best thing would be to start with Spring Web Flux. And I would recommend first try to read upon what is reactive programming, and then what are the primitives, like understand what is a publisher, what is a subscriber, what is a subscription, and what steps you typically have, like on next, on error, on complete, these kind of things. So first, get a good grasp of these fundamentals. Surprisingly, the very core of reactive programming is very small. If you see in Java 9 Flow, hardly there are 3 or 4 classes. That's it. That's a whole reactive programming. So first, get a good grasp of those things, and then probably you can start using Spring Web Flux. And then I would say again, go in a step-by-step manner. Don't try to understand every bits and pieces of it. First, try to establish a common flow. Okay, how do you use reactive programming API? And then talk to, let's say, MongoDB with reactive driver. And then you can explore further project reactor. There are a lot of features, operators, like you can merge streams, and you can unzip, zip. So there are a lot of things that you may need or may not need.
Absolutely. Cool. Um, your thoughts on that, Kaushik?
Yeah, I agree with what Shiva said. The other thing I would say is echo back to what you mentioned earlier, Ranga. I think functional programming knowledge is critical. So I would recommend somebody who's starting with reactive programming, get good at working with streams, collection streams, chaining operators. They're not called operators with collections. Chaining all these different methods to process, and kind of get familiar with that. Get familiar with creating these chains of lambdas and operating on them. And then once you do that, I think a good place to start would be Spring Boot and Spring Web Flux. There are guides on the Spring website which talk about how to do the traditional way versus the reactive way. So I would look at that and then try building some examples and then playing with operators. That would be the next step. I don't know if a self plug is okay. I'm actually planning to have a free class on reactive programming with Java. So people who are listening, if you're interested, go check it out on my website, www.javabrains.io. Um, that's one way, but I cannot promise when it is. But at a high level, those would be my recommendations for the steps. First, functional programming, get comfortable with streams and operators and all that, like chaining things, and then go from there to Spring Web Flux and building reactive APIs, right? Have controllers which return a Flux or a mono and kind of understand the implications of that. And then from there, go to the operators, learn how you can manipulate these things, learn how you can manipulate asynchronous operations as well, address some common scenarios, and then learn how you can transform these events over time and build a complete chain of reactive. So that would be my recommendation.
Thank you, Kaushik. I think that's a wonderful summary. So, like, start with functional programming, understand the React fundamental interfaces, and then probably go and build up some applications related to that. Cool. Thanks a lot, Kaushik. Thanks a lot, Shiva. It was wonderful having you guys in here to discuss about this. For the viewers, if you have any other topic suggestions that you'd want us to discuss on, please do post them in the comments, and we would discuss about them as well. Thanks a lot. And until I see you again, here's bye from Ranga. I'm sure you had a great time watching this video. If you loved this video, do not forget to like, share, subscribe, and comment as well. Our goal at In 28 Minutes is to help you learn cloud DevOps and also programming. So go ahead, keep learning every day, and I'll see you again.